Yes, students, as you all know, in the last class, we were discussing the chapter chemical reactions and equations. In that, we come across the different types of chemical reactions. And with respect to that, we used to get the more information, detailed information. In particularly in yesterday's class, we focused on activities related to first two types of chemical reactions. One is chemical combination. Second one is chemical decomposition or just decomposition reaction. With respect to chemical combination or combination reaction, the first activity was, it is burning of magnesium ribbon, right? So, and we know that when the magnesium is burned in the air, then it reacts with oxygen present in the air and produces a white powdery mass called magnesium oxide. Then its balanced equation is, it is 2MgO and here is 2Mg. And in that, a very important point is, before burning a magnesium strip or magnesium ribbon, it is to be rubbed with a sandpaper. We know the reason for this. Because to remove the unwanted impurity called basic magnesium carbonate, so that it can easily react with the oxygen on burning, right? And this basic magnesium carbonate is a combination of two chemical compounds. What are those? One is magnesium carbonate, second one is magnesium hydroxide. Next, the second activity was, it is reaction of calcium oxide with water. We know that the reaction between these two is very vigorous. So as soon as the water is added to the beaker containing the calcium oxide crystals or calcium oxide pieces, the immediate reaction takes place. So it appears as if it is like a boiling, and also there will be very small sparks on the surface of the calcium oxide pieces, is it not? And when you touch the beaker, you feel it is hot. And in this chemical reaction, the two reactants are, one is calcium oxide, second one is water. These two together react with each other to form a compound called calcium hydroxide, right? And the chemical equation was written like this: CaO plus H2O gives rise to, it is CaOH twice. And even it was also balanced. What is the balanced chemical equation of this? It is already balanced, right? One atom of calcium, one atom of calcium. Two atoms of hydrogen, two atoms of hydrogen. But one atom of oxygen is there. How do you go for balancing it? It is. Can I write here two? Yes or no? Two atoms of oxygen. Here, two atoms of oxygen. Now, how many atoms of hydrogen? Two twos are four. Four atoms of hydrogen. Here, only two are there. Then, if I write two, again it will be more. Then, how do you go for balancing it? Prashant sir, you may unmute some students.
Sir, it is already
Sir,
balanced.
it's already
Balanced, sir.
Already balanced, sir.
Balanced. Oxygen is 1 plus 1, sir.
Sir, you're muted.
Unmute your audio, sir.
Sir, unmute your audio.
Sir, unmute your audio.
Unmute your audio, sir.
He knows that. He knows that. Keep quiet.
Yes. Here, two atoms of oxygen. Here, two atoms of oxygen. Already it is balanced. And then after that, we come across one of the important information from this. What are the calcium oxide? Calcium hydroxide is obtained. This calcium hydroxide is used for whitewashing. And you also know that when this is apply to the wall get shiny appearance after 2 to 3 days. Is it not? Then the reason for this, so this calcium hydroxide will react with carbon dioxide present in the atmosphere slowly and forms a thin layer of a shiny chemical substance called calcium carbonate. As a result of it, wall get shiny appearance. And we wrote the chemical reaction, chemical equation related to this. It is calcium hydroxide, CaOH twice, plus carbon dioxide, CO2, gives rise to, it is calcium carbonate, CaCO3, plus H2. Here, is it balanced or yet to be balanced? Calcium, 1 atom. Oxygen, 2 plus 2, 4. Here, 3 plus 1, 4. Hydrogen, 2. Hydrogen, 2. It is already balanced. Please do remember, the solution which is used for whitewashing is calcium hydroxide. And the chemical substance from which the chemical substance from which a solution is obtained, which is used for whitewashing, it is calcium oxide. So please do remember. Now, even we come across one more activity which is related to chemical decomposition reaction or just decomposition reaction. Then what was that activity? It is heating
Composition of ferrous sulfate.
Heating of ferrous sulfate. We know that color of ferrous sulfate is,
Pale green.
Pale green color, light green color.
Pale green.
And this green color is due to the presence of the fixed molecules of water in one formula unit mass of ferrous sulfate. So then in one formula unit mass of ferrous sulfate, how many water molecules will be present?
7
water molecules. And you know that when it is heated, all the amount of water gets removed. Then this iron sulfate or ferrous sulfate changes its color from pale green to white. When you continue to provide the heat, then it undergoes decomposition, which means that it gets split up into some compounds. Among them, one is sulfur dioxide. You will come to know that by inhaling the smell. So when you inhale the smell of sulfur dioxide, you will have the feel of coughing. And when you continue to provide the heat, then afterwards you will experience a smell of rotenate that indicates sulfur trioxide gas is also being released. Then at last we will get a brown residue. We call it as ferric oxide. It is Fe2O3. And even we balance this also. So for balancing, which element was chosen? Yaudo? Iron was chosen. Oxygen cannot be considered, as oxygen has been distributed to three compounds. So that is why we will go for taking iron. Here 2 atoms of iron. Here we will take 2 atoms. See that 2 atoms of iron, 2 atoms of iron, 2 atoms of sulfur, 2 atoms of sulfur. Oxygen, 2 4s are 8 atoms of oxygen. Here 3 plus 2 plus 3, it is 8. Right? This much was completed. Okay. Now let us continue today's class. But as I said, every day we will go for balancing just 2 chemical equations. Today also, I'll take only 2 chemical equations. Then afterwards, we'll move on to the next activity. So right, side heading, balance chemical equation. In this, The first one is, it is aluminum. It reacts with copper chloride, CuCl2. Yes, students, you all know that aluminum is more reactive than copper. Is it not? It can displace copper from copper chloride. Could you tell the compound that is formed? Yes.
Aluminum chloride plus copper.
Aluminum chloride, AlCl3 plus
Copper.
copper is separated. Now it should be balanced. See that here, you no need to go for listing the number of atoms. Directly you can go for balancing it. Balanced chemical equation is, here I'll write it again, Al plus CuCl2 gives rise to AlCl3 plus Cu. You just observe here, which element has maximum number of atoms. Just by observation, you know it is chlorine. Here 2 atoms are there, here 3 atoms are there. Now they should be balanced. How do you go for balancing? Multiply
3.
multiply 2 by 3 and 3 by 2. See the 2 3s are 6. Here 3 2s are 6. I'll write here 3 and here 2. Now you may count 3 atoms of copper. Sorry, 3 2s are 6 atoms of chlorine. Here 2 3s are 6 atoms of chlorine. And copper, 3 atoms are there, but here is 1 atom. Hence, we can write here
3.
3. Followed? 3. Next,
2 aluminum.
aluminum.
2 aluminum, 2.
Here is
2, sir.
1. We can write here 2. This is a simple one. I'll go for taking 1. And this was given in the examination as well. They had given the chemical reaction only. They had given the chemical reaction and they had asked you to write the chemical reaction in the form of word equation as well as symbolic equation, and also it should be balanced for 2 marks. Half marks for writing the word equation and half marks for writing the chemical equation and 1 mark for balancing the chemical equation. Just I'm going to give you the same. Here, barium chloride solution reacts with aluminum sulfate. Barium chloride. Please write with me. Barium chloride. Barium chloride. It is aqueous solution. Means prepared using water. Barium chloride solution reacts with aluminum sulfate. Aluminum sulfate. This is also an aqueous solution. Dear students, you all know that when 2 aqueous solutions react with each other, we get a solid chemical substance which is insoluble in the solution. It is precipitate. What is that precipitate?
Barium sulfate.
Barium sulfate. Barium sulfate. Then plus an aqueous solution of aluminum chloride is formed. Aluminum chloride. See, they have given the chemical reaction. We have converted this into word equation. Now let's go for writing its symbolic equation. Symbolic equation. Barium chloride. Its chemical formula is BaCl2 plus aluminum sulfate. It is Al2SO4 thrice. To write the chemical formula, you must know their valencies are charges. Here, if you come across barium chloride, it will be Ba2 plus Cl1 minus. Here, aluminum sulfate. Aluminum Al3 plus sulfate SO4 2 minus. I'm crossing over charges, it will be Al2SO4 thrice. Next, barium sulfate. See, Ba2 plus SO4, 2 minus. Hence, the chemical formula will be BaSO. Next, aluminum chloride. Al3 plus Cl1 minus. Crossing over charges, it will be AlCl3. Got it? Now it should be balanced. Let's go for balancing it. This is also very simple. Because here you can come to know that atoms are not distributed to 2 or 3 different compounds. Now, which element can be considered for balancing?
Oxygen, sir.
Oxygen. This is oxygen has maximum number of atoms. You know, 3 4s are 12. Here 4 is there. Then what should be multiplied? What should be multiplied?
3, sir. 3.
3 should be multiplied into 3. Here 3. Now 3 4s are 12. 12 atoms of oxygen. Here 3 4s are 12. 12 atoms of oxygen. Whereas barium 3 atoms. 3 atoms. Here is only
Multiply 3.
1 atom. Can we multiply 3 here? If you multiply 3 there, barium is balanced. Next, sulfur. See the 3 atoms of sulfur. Already it is there. Next, whereas chlorine, 3 2s are 6. 6 atoms of chlorine. Here only
Multiply by 2, sir.
3 is there. Here 6. Here is 3. So it should be multiplied by 2. Here are right. 2. Next, aluminum. 2 atoms of aluminum. There are 2 atoms of aluminum. So it is balanced. Yes. Hope that you have understood. Now we will focus on today's concept. Yes, students, you all know that in yesterday's class we were focusing on activities related to different types of chemical reactions. Among them, the first one was over completely. Second one was being discussed. In that one activity, the second one was it is decomposition reaction. In that one activity was it is heating of ferrous sulfate. Right? This was over. Now I'm going to take another activity which has been given in the textbook only. This is lead nitrate. Heating of lead nitrate. Right? Activity 2. Activity 2. This is right to show heating of lead nitrate. Lead nitrate is decomposition reaction. Decomposition reaction. Heating of lead nitrate is decomposition reaction. Let's go for taking this activity. You all know that to conduct this activity, we need some of the apparatus. Obviously, one is boiling tube. Second one is lead nitrate crystals. Third one, Bunsen burner. Then test tube holder. These are the operators required. Let us come to know how to arrange them through a diagram. Here, as we need Bunsen burner, first let me go for drawing. Draw quick as possible. Please go on drawing with me. Draw just a cylinder. This is a Bunsen burner. Here I am showing the gas one. Next, let me draw test tube. This is test tube. In which we'll go for taking some crystals of lead nitrate, PbNO3 twice. This is its chemical form, and it should be fitted to a test tube holder. This is test tube holder. This is an experimental arrangement. Have you drawn? Okay, you may stop writing. First, just listen to me. Hope that you have finished. Chandana, Aitanama? Okay.
Yes.
Pawan, have you drawn? Adil Malik? Tushar? Okay. Sneha? Okay, very good. Disha, yes, Kamble? Okay. Yes. Somesh? Have you drawn? Okay. Then stop drawing. Samiksha, still you are drawing. Observe the book. Very simple arrangement. First, we have taken some crystals of lead nitrate. You know that the color of lead nitrate crystals. Can you tell? It is white. Please do remember, color of the crystals of lead nitrate is white. Some crystals are taken in a test tube. Then it should be fitted to a test tube holder. Then introduce that or place or start heating the test tube in the Bunsen burner flame. Do you know what will be your observation? Samiksha, please don't draw. You will observe that brown fumes will be coming out from the test tube. Brown fumes start agutte. Do you know what are these brown fumes indicate? These brown fumes are, it is brown fumes. It is nitrogen dioxide gas. Nitrogen dioxide. Then when all the amount of brown fumes are completed, then take a lighted matchstick and bring it near the mouth of the test tube. You'll notice that this lighted matchstick burns still brighter. If it is burning brighter means you can come to know that it is obtaining additional oxygen. So from this we can also conclude that in this chemical reaction, oxygen gas is being evolved. Then after that, when you observe the residue that is which is left in the test tube, you'll come to know that it will turn to yellow color. Do you know what is that yellow color compound? Aditi, could you tell?
Lead
what is
oxide.
the yellow color compound?
Oxide.
It is lead oxide. Now let me go for writing the chemical equation. Just observe. Here we have taken lead nitrate lead nitrate crystals, and it has been heated, and heating. Brown fumes will be coming out, which indicate nitrogen dioxide gas is being liberated. Then, when you bring a lighted matchstick or else burning incense stick near the mouth of the test tube, or else just place it inside the test tube, it will, the burning incense stick, it glows brighter. If lighted matchstick is brought, it start burning still brighter. So which indicates oxygen gas is released. Then at last we get a yellow color residue, which is called lead oxide. It is PbO. Aditi, yes, followed. Good girl. So here you can come to know that one reactant is there. On heating, it gets split up into 3 compounds. So the phenomenon of the chemical reaction in which a single substance gets split up into 2 or 4 compounds is known as decomposition reaction. Therefore, it is a decomposition reaction. Clear? Got it? Yes. Now, let me go for writing the procedure. It's very simple. Go on writing it. Yes. Procedure. First point. What is the first point? Take some crystals of lead nitrate in the test tube and fix it to a test tube holder. This is the first. Take some crystals of lead nitrate and lead nitrate in the boiling tube or test tube. The boiling tube. Then fix it in the test tube holder. Fix it in the test tube holder. Next, second point. What is the second point?
Introduce it to the flame.
In the Bunsen burner flame. Heat the test tube. Heat the test tube in the Bunsen burner flame. Please go on, write it with me. Don't be lagging. Bunsen burner flame. Then, after this is the procedure. Next point is, it's about observation. What is our observation? We will observe that brown fumes of nitrogen gas is coming out, right? It is observed that brown fumes releasing or liberating, which indicates nitrogen dioxide, Next, and when burning mastic is brought near the mouth of the test tube, what happens?
It burns brightly.
Burns brighter, which indicates it is obtaining additional oxygen. From this, we can conclude that in this chemical reaction also, oxygen gas is released. Right. Another point, when burning mastic is brought near the mouth of the test tube. Mouth of the test tube. It burns. It burns brighter, which indicates oxygen gas is evolved. Oxygen gas is liberated. Oxygen gas is liberated. Next, the third observation is when the reaction completes, then lead nitrate crystals turn to yellow, which indicates lead oxide is formed. Right. When the reaction completes, the residue.
Android blue droid. Android blue droid. So who's this person? Please rename. Android blue droid. Please rename.
Sir.
When the reaction completes, the residue in the test tube.
Sir.
Yes.
What is after matchstick brought near 4th point second line?
When the burning matchstick is brought near the mouth of the test tube.
Okay.
Venkateshas, do you have been writing or not? Show me. Show me. Show me your writing. Sir, he turned off his video. He is not writing anything.
Removing.
Okay. He is showing, sir. He is showing. Okay.
When the reaction completes, the residue in the test tube is yellow color, which is lead oxide. Now let me go for writing the chemical equation which represents this reaction. It is lead nitrate PbNO3 twice gives rise to this on heating, it decomposes into lead oxide, that is PbO, nitrogen dioxide, it is NO2, plus oxygen gas is liberated, that is O2. Now let's go for balancing. So, which is to be considered for balancing?
Nitrogen, sir.
Nitrogen, sir. Very good. Here it is 2. Here is 1. If you take this 2, this is 1, then obviously it should be multiplied by 2. Okay, I'll write 2 here. Next, observe oxygen. 2 2s are 4 atoms of oxygen. Here 2, 4 plus 2, 6, 6 plus 1, 7. But here oxygen is 3 2 the 6. Oxygen is not balanced. Then here, right, just P, the elements that are involved are lead, nitrogen, and oxygen. And on the left hand side, that is on the reactant side, Lead has only one atom. Nitrogen has here 2 atoms, whereas oxygen 3 2s are 6 atoms. And on the right hand side, that is on the product side, lead has only one atom. Nitrogen has one atom. Oxygen has 1 plus 2 plus 2. 1 into 2 into 1 plus 2 plus 2. 5 atoms. Then obviously we will go for considering nitrogen. Here is 2. It should be multiplied by 2. But just we came to know that when you multiply by 2, it is not balanced. Nitrogen matra balance agate, but oxygen is not balanced. So the best thing what we can do.
First oxygen should be taken, sir.
If you go for considering the oxygen atom, but how do you go for balancing it?
2 PbO.
5 into 6 and 6 into 5.
2 PB, sir.
Sir, 2 PbNO3 by
2
2.
BB.
But there is
2
only
PbO, sir.
already lead is balanced, no? Then how do you go for taking?
Sir, last O2 we can take half, no, sir. Half O2.
No. Here we are not going to take half. We will just go for taking only the whole numbers, or just natural numbers. And then thought fractions adella, our method ella namigilla. Just we are going to use only the whole numbers. Obviously, look here. When the nitrogen is being inside, nitrogen is being balanced. Other atoms are not being balanced. So that is why I'll go for taking lead only. Here, one atom of lead, one atom of lead. If I take 2, when I multiply both by 2, it will be 2 atoms and 2 atoms. Just observe. 2 atoms of lead. Here, 2 atoms of lead. Now you just observe how many atoms of nitrogen. Okay, 2 2s are 4, 4 1s are 4. 4 atoms of
4 atoms.
here already 1 atom is there.
Sir, 2 PbNO3 twice is give rise to 2 PbO plus 2 NO2 plus O2, sir.
Yes, once you tell.
Sir, 2 PbNO3 twice is give rise to
Sir, it is balanced, sir.
2 is telling me
2 PbO plus 2 NO2 plus O2, sir.
2 NO1. If you write here 2, look here 2 atoms of nitrogen. Here 4 atoms of nitrogen. Hence it won't be balanced. That's why we are multiplied by 4. See that 2 atoms of lead, 2 atoms of lead. Nitrogen 2 2s are 4 atoms of nitrogen. Here 4 atoms of nitrogen. Next oxygen 2 3s are 6, 6 2s are 12 atoms of oxygen. Here you count 4 2s are 8, 8 plus 2 10, 10 plus 2 12 atoms of oxygen. So even oxygen is also balanced. Clear? Aditi? Okay. Now, here one compound gets split up into 3 compounds. That is why it is called decomposition reaction. Just below that, right? This is decomposition reaction. Decomposition reaction. Okay. Now we are moving to the next activity. And this activity is most familiar to you because you have also come across the activity in your previous classes as well. The students, now I go for taking a compound called water. Its molecular formula is H2O. Does it undergo decomposition? Means
Yes, sir.
whether this compound gets split up into 2 or more compounds?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
H2 if so,
Hydrogen
under
and
what
oxygen.
condition
Hydrogen and
it
oxygen.
gets split up?
Electricity is passed.
Yes.
When electricity is
Your
passed.
students, in your previous
Passed in
class
water.
only, you have learned that when electricity is passed through water, it gets split up into hydrogen and oxygen. And even you have called this phenomenon as, or this
Electrolysis of water.
Electrolysis.
Electrolysis of water. That is, when electricity is passed through water, it gets decomposes into hydrogen and oxygen. This is known as electrolysis of water. Afterwards, I'll give you the definition of it. Just your concentration should be here. As one compound gets split up into 2 other compounds, therefore it is a decomposition reaction. Now, we have to show that with an activity. That is, we should show that electrolysis of water is a decomposition reaction. Please go for writing. Activity 3. Activity 3. It is to show electrolysis of water. Electrolysis of water is decomposition reaction. Is a decomposition reaction. Aditi, have you copied? Okay, listen. The experimental arrangement is also very simple. Just recall the definition of electrolysis of water. When electricity is passed through acidified water, it gets split up into hydrogen and oxygen. So electricity has to be passed. Then how do you go for passing electricity? With the help of a simple circuit and electrodes. Then what are electrodes? We know that electrodes, they are nothing but the solid substances which allow the electric current when they are immersed in the solution. Right? We go for taking copper electrodes, iron electrodes, zinc electrodes, like that. Even one of the electrode, which is a non-metal and is a good conductor of electricity. Which is that?
Carbon, sir.
It is the only non-metal which conducts electricity. That is carbon in the form of graphite. So here we will also go for using graphite. Simple circuit, graphite rods, then water. Clear up? Let's go for experimental arrangement. It's very simple. Just I'll go for explaining it briefly. Don't go for drawing. And first briefly, rough sketch I'll show you how to draw that. Then afterwards, you can draw with me. Look here. Here in this experiment, we will go for taking an inverted glass bottle, a glass bottle having no bottom. Okay, this is, and it is to be fitted to the iron stand invertedly like this. Here it is fixed one. Then we will go for closing the mouth of the glass bottle or a plastic bottle with 2-hole rubber cap. Then after that, we will insert electrodes in each of these 2 holes. Next, free ends are connected to terminals of a battery along with the switch. Please don't draw, observe. Afterwards, we will go for filling 3/4 of this bottle with water. Next, and we will take two test tubes and we will mark them as A and B. Fill them with distilled water and place these invertedly on each of these electrodes. Clear? This is an experimental arrangement. Once I repeat, okay. Take a glass bottle having no bottom. Next, fix it to the iron stand invertedly. Next one. Close the mouth of the bottle with two-holed rubber cork. Next one. Insert graphite rods in each of these holes. Next, connect the free ends of the graphite rods to the terminal of the battery along with the switch using the copper wire or a conductor. Next, fill the glass bottle, 3/4 of the glass bottle with water. Another point, take two test tubes, mark them as A and B. Fill them with distilled water. Then place invertedly to cover each graphite rods. This much experimental arrangement. So now with respect to that, I'm going to draw the figure neatly. You should also draw with me. Please start drawing. First, I'm going to draw the glass bottle or else glass jar. Here I'm drawing that. Observe the way I'm drawing and please do follow the same. This is a glass bottle or the glass jar having no bottom. And the bottom has been removed. Next, we go for taking a rubber cork and close the mouth of the glass bottle with two-holed rubber cork. This is. Next, take graphite rods and insert them in each of these holes. Here I am showing that the graphite rods. These are two graphite rods. If you go on drawing quickly, don't decorate it. You have to finish up it as quick as possible. Next, connect the free ends to the terminals of a battery along with the switch. Here. These are the two graphite rods. We are going to connect them to the terminals of a battery. I'm going to show the battery like this. This is a battery of about 6 volt, 12 volts. Just here I'm writing 6 volt. Let us take this terminal as positive and this terminal as negative, along with a switch. Next, we know that this arrangement should be fitted to, that is, glass jar should be fitted to iron stand. Here I am drawing that. Observe and draw However, I am drawing. It is important in the examination point of view. Even they'll ask you to draw the figure related to this. This is iron strand. You have to finish off it with me only. Don't take separate time for that. Next. You know that 3/4 of the bottom is filled with water. And after that, we will go for taking 2 test tubes and fill them with the distilled water. And you can mark them as A and B. This first one is A and second one is B. Hope you have finished. Anushka, have you finished? Amruta is Belludi. Varsha MS, finished. Basavan Gowda. Okay. Savano. Preeti came.
Sir, excuse.
Andanu.
Sir, excuse, sir.
Shankar, have you finished? A bit is there. Okay. Finish of it quick as possible. Adya. Karan Gowda. Finished up. Hitesh. Chaya. Chaya B. Madhavi. Okay, then observe it. Now let me go for explaining the procedure. Experimental arrangement is over. Now the procedure. Observe carefully. Anjikemat, observe. Naksha, look at the book. Observe. Here, we have made an arrangement of the activity related to electrolysis of water. So this is glass jar having no water, and these two are test tubes. These two are graphite rods. This is rubber cup and is conducting wire. This is a battery and is switch. This is iron strand. Experimental arrangement I have already told you. Now we are moving to the procedure. See, after covering these two electrodes with the test tube, then you go for closing the circuit by switching on. When circuit closes, the current flows from positive terminal to negative terminal. Right? Then you can notice that the bubbles are formed near the electrodes, and these bubbles are filled with gas, and these bubbles will start displacing the water. Water na displace ಮಾಡ್ತಾ ಹೋಗುತ್ತೆ. Displace ಆಗ್ತಾ ಹೋಗುತ್ತೆ. Now I'm showing that. And when you leave it for some time without disturbing it, you will notice that in one of the test tube, the amount of gas filled in one of the test tube is double of the other. I am showing that one. This is water. Hope that you are able to see it properly. Could you tell in which test tube more amount of gas is filled?
A, sir.
It is A or B?
A, sir, A.
More amount of gas
B, sir.
Negative.
B, sir.
B. Andre, it has displaced more amount of water. And this much amount of gas is there. And here only this much. Compare those two. And comparing, you will come to know that the amount of gas filled in B is double of the amount of gas filled in A for some unit time. Followed. Then after that, again you leave it. Then all the water present in the test tubes get displaced. So the test tubes are filled with gases. Then take the test tubes one by one and go for testing them. Which gas is being evolved? See, I'll go for taking the first test tube A. Don't draw, just observe. And next one, it is B. Here, and bring a lighted mastic nearby. Both. You'll come to know that in the first test tube, the lighted mastic start burning brighter, which means which gas is being released here?
Oxygen.
Oxygen, sir.
Oxygen. It burns brighter means it is obtaining additional oxygen which is available from the water. Next, similarly, you will bring the lighted mastic nearby the mouth of the test tube B, and this here the flame
Pop sound.
and it will produce the pop sound. You know that pop sound indicates hydrogen
Liberation
gas
of hydrogen.
liberated. Clear up? So here, from this experiment, we can come to know that water gets split up into hydrogen and oxygen. And here, look here, the amount of gas filled in both is different. The amount of gas filled in test tube B is double of in test tube A. Then what does it indicate? It indicates the amount of the particular gas or the number of atoms present in that water. One element has the atoms double than the other element. Here you'll come to know that hydrogen is released in B. Oxygen is released in A. And it was in the ratio 2:1. Amount of gas filled in test tube B is double of the amount of gas filled in A, which indicates here water molecule is formed by 2 atoms of hydrogen and 1 atom of oxygen. Did you understand?
Yes.
Students, just one more information. You all know that with respect to electrodes, these electrodes are also named particularly. The electrode which is connected to negative terminal of a battery, we call this as, it is cathode. And the electrode which is connected to positive terminal is known as anode. Do remember.
Cathode.
Followed? Any doubt regarding this?
No.
No doubt. Akansha MG, any doubts? Manya? If no doubts are there, now I'll go for writing the procedure. Danvit, any doubt?
Ashutosh Bijay.
Sir, explain again, sir.
Ashutosh Bijay.
Yes. Now just beside this figure, you may go for drawing these. Draw the test tube A as well as B.
Sir, we should draw A and B, sir.
Yes, both A and B. Pick up Baribeko. Anup Bhaiya, have you copied? Now, here I'll write the procedure. I'll write the arrangement in procedure only. What is the first point? Take a glass jar or plastic jar having no bottle and fix it to the iron stand invertedly. Rightly. Take a glass jar having no bottom and fix it to the iron stand invertedly. Next point. Vishwath copied? Yes, okay. Next point ಏನು ಅಂತ ಹೇಳಿದ್ರೆ close the mouth of the glass jar with 2-hole rubber cap. Right. Close the mouth of glass jar with the 2-hole rubber cork. Next, what is the next point? Then we will go for taking the electrode, that is graphite rods. Insert the graphite rods in the 2 holes. Here only I'll continue. And insert the graphite rods in it. Insert the graphite rods in it. Third, okay, we are going to connect the graphite rods to the terminals of a battery along with the switch using conductor. And it is very easy to understand. Right. Connect the free ends of graphite rods to the terminal of a battery. Terminals of a battery along with the switch. Using a conductor or using a copper wire. Using a conductor. Next, another point. What is that point? Now we have to take 2 test tubes, name them as A and B, fill them with distilled water. Sorry. We have to fill 3/4 of the glass jar with water. And to make it as more conducting, you can go for adding dilute HCl or dilute H2SO4 also. Here, you just mentioned that. It is H2O plus dilute HCl. Right. Fill 3/4 of the jar. 3/4 of the jar with water, acidified water, with acidified water. If you go for taking only the distilled water, as distilled water is free from salts and minerals, it won't conduct the electricity. To make it as conducting electricity, we will go for adding small amount of dilute. Fill 3/4 of the jar with acidified water. Next point. You go for taking 2 test tubes, name them as A and B, fill them with distilled water and cover, place them invertedly to cover the graphite rods. Right. Take 2 test tubes. Test tubes. In bracket you write A and B. A and B. Fill them with distilled water. Fill them with distilled water. And place them invertedly to cover the graphite rods. Hope you are written. Take 2 test tubes A and B, fill them with distilled water and place over 2 graphite rods invertedly, or else place them invertedly to cover the graphite rods. Clear? Next one. Look here. Test tube A is placed invertedly on the graphite rod which is connected to positive terminal, and test tube B is covered. It has covered graphite rod which is connected to negative terminal. Please do remember that. No need to go for writing again. Well, next. This is the arrangement. Next is procedure. What is that procedure? It is switch on. When you switch on, we know that current starts going from positive terminal to negative terminal of a battery. Just you write.
Excuse, sir.
Allow the current, right, to pass through water. Allow the current to pass through water. Then what will be, and leave it for about 10 to 15 minutes. Then after that we have to observe. Allow the current to pass through water for about 10 to 15 minutes or for some time. 10 to 15. Yeah, generally we have taken 10 to 15 minutes. Even 5 minutes will also be enough. Next, we have to write the observation. What will be our observation? We will observe that the amount of gas collected in test tube B is double of gas collected in A. Right? That is first observation. Right? It is observe that the amount of gas collected. You ಇನ್ನೊಂದು point ಅನ್ನು extend ಮಾಡ್ತೀರಿ ಅಂದ್ರೆ you can also write like when the current is allowed for about it is noticed that the gas bubbles are formed near the electrodes, which means They are displacing the water present in the test tube. It is observed that gas bubbles are formed near each electrode. Here each electrode. Here each electrode, which indicates water present in the test tube. Water in the test tubes is being displaced. Here I'm continuing this. Is being displaced. Next, one more point. The point is the amount of gas collected in test tube B is double of the gas collected in A. Right. The gas collected in test tube B is double than in test tube A. Test tube A.
Sir, what is that, sir? Last point, which indicates last point, sir. Last point here, right side.
One, sir.
When all the amount of water get displaced from the test tube, we will go for testing the gases with the lighted matchstick. Right. When all the amount of water in the test tube displaced. Remove the test tubes. Test tubes one by one, and check the gas released. Is using lighted matchstick. Next point. Another point. Right. It is noticed that when the matchstick is brought, or when the burning matchstick or lighted matchstick, when the burning matchstick is brought near the mouth of test tube A. Test tube A, matchstick burns brighter. Which indicates oxygen gas is evolved. Oxygen gas is evolved. And test tube B. Test tube B. That is, when the burning matchstick is brought near the mouth of the test tube B, and we notice that it produces the pop sound. Test tube B, it produces pop sound. Pop sound, which indicates hydrogen gas is liberated. Hydrogen gas is liberated. Now, with respect to this, we can write a chemical equation as H2O gives rise to, here we know that it undergoes decomposition by passing electricity, right? Electricity. Then by passing electricity into the water, it gets split up into hydrogen and oxygen. Please go for balancing it. Here, oxygen can be balanced. 2 atoms are there. Here are like 2. Whereas hydrogen, 4 atoms are there. Here is already 2. You can write 2. So this is decomposition reaction. This is decomposition reaction. Decomposition reaction. Written up. Okay. Now, dear students, I'll give you some of the important points with respect to this activity. One is definition of electrolysis of water. Very simple. When electricity passes through the water, it decomposes into hydrogen and oxygen. This is known as electrolysis of water. Right. Right. Note in that.
Sir,
first
explain slowly, sir.
It is electrolysis of water. Electrolysis of water. Right. When electricity is passed through water, it decomposes or it split up into hydrogen and oxygen. Hydrogen and oxygen. Hydrogen and oxygen. This is known as electrolysis. This is known as electrolysis. Second, we know that amount of gas collected in the test tube. Test tube B is double of test tube A. That means the amount of hydrogen gas present in test tube B is double of amount of oxygen gas present in A. So that can be written as 2:1. S2 is to O2 is equal to 2:1. Next point. We know that the electrode which is connected to positive terminal is anode, which is connected to negative terminal is anode, is cathode. So, right. Electrode connected to positive terminal is positive terminal of a battery is anode. Is anode. Nearby anode, which gas is released?
Oxygen, sir.
This is simple. We know that oxygen is affinity towards positive terminal. This is. It is oxygen is. Its ion of oxygen is anion, negatively charged ion. It is affinity towards positive terminal. So that is why we can write the anode next. And electrode connected to negative terminal. Electrode positive terminal. Negative terminal. Is cathode. Cathode. Next. So hydrogen is formed nearby which electrode? Anode or cathode?
Cathode.
Anode. Right. Hydrogen is formed nearby cathode. Next, oxygen is formed nearby anode. Overall, yes, students, one more activity is there with respect to this. This is very simple. Here only I'll go for writing. Activity 4. Activity 4. Okay. Dear students, I'll go for taking a compound called silver chloride. Silver chloride, which is white in color. When it is exposed to the atmosphere exposed and in the presence of sunlight, it loses its color from white to gray. That gray color indicates silver chloride gets split up into two compounds. They are, one is silver and another one is chlorine. So this is also an example for decomposition reaction. And now we are going to take an activity to show decomposition reaction of silver chloride. Right. To show decomposition reaction. Decomposition reaction of silver chloride. Silver chloride. For this, I won't go for giving you the procedure. Just go for drawing the figure and let's go for writing the chemical equation. Here. This is the experiment table and this is a china dish. Or else you may go for taking watch glass also. In this, you have taken some amount of silver chloride. It is AgCl. And it is to be placed in the sunlight. It is placed in the sunlight. Then in the presence of sunlight, it decomposes into silver and chlorine. So here I write its color is gray. So it is white. Then it implies black. Here I am writing. This is china dish. In that a gray color residue will remain. It is Ag plus Cl. Cl2. Over. Here I will write the chemical equation. Just below that figure, you may write this. AgCl. In the presence of sunlight, it undergoes decomposition reaction and forms the compounds called silver and chlorine. And balancing is also very simple. Here chlorine 2 is there, right? Here 1 is there, right here 2. Then 2 atoms of silver, right? 2 atoms of silver. So this is decomposition reaction. This is decomposition reaction. Ora. Finished? Anaga,
No, sir.
finished, huh? Okay, very good. Observe. Observe. Stop writing. Stop, madam. Nan jotege barita hodre ನೀವು ಎಷ್ಟು ಬೇಗ ಮುಗಿಸಬಹುದು. If you are busy in other activity, it will be late. Dear students, now I am going to take any 3 chemical reactions that we use in decomposition. We have come across total 4 activities, right? Among these, I'll go for taking 3 activities. One activity is, just observe, lead nitrate, PbNO3 twice. Dear students, you all know that lead nitrate undergoes decomposition reaction. What is the condition under which it undergoes decomposition reaction?
Lead oxide.
Sir.
Heat, sir.
Heat, sir.
Heating and split up into lead oxide PbO, nitrogen dioxide NO2, and
Oxygen.
Right. And second one, another activity. In another activity, even we have come across decomposition reaction of water. Under what condition water gets split up into hydrogen and oxygen?
Electricity, sir.
Electricity is passed through water. It gets split up into hydrogen and oxygen. And even we have come across AgCl undergoes, that is silver chloride undergoes decomposition reaction, or it
Sunlight.
In presence of sunlight.
Under what condition?
Sunlight, sir.
Sunlight. Yes, students, from these 3 observations, you will come to know that decomposition reaction is carried out under 3 conditions. One is supplying heat.
Electricity and sunlight.
In the presence of, by passing electricity. Third one is in the presence of sunlight. Follow? These are the 3 ways in which decomposition reaction takes place. These are the 3 ways in which decomposition reaction takes place. What are those? The first one is
Heat.
by supplying heat. Second one is by passing electricity. Third one is in the presence of
sunlight.
Dear students, for each of these reactions, we have given a particular name. If the decomposition reaction is carried out by supplying heat, it is called
thermal
decomposition reaction. Thermal decomposition reaction. Chayayam, observe. Next, if the decomposition reaction is carried out by passing electricity, it is called electrolysis. Then third one, if the decomposition reaction takes place in the presence of sunlight, it is called photochemical reaction. Photo means light. So as this decomposition reaction takes place in the presence of sunlight, it is called photochemical. So these are the 3 important types of decomposition reaction. Got it? Suraj, let your concentration be here.
Yes, sir.
Once I remind you, decomposition reaction is carried out in 3 ways or under 3 conditions. One is by supplying heat, second one is by passing electric current, third one is in the presence of sunlight. And the name that has been given for each of these chemical reactions are these: thermal decomposition reaction, electrolysis, and photochemical reaction. Let me just give you the definitions of these. First one, thermal decomposition. The decomposition reaction which is carried out by supplying heat is called thermal decomposition reaction. And this is an example. Suraj Chandra. Next, if the decomposition reaction is carried out by passing electricity, then it is called
definition, sir.
electrolysis.
Sir.
And an example. Third one, if the decomposition reaction is carried out in the presence of sunlight, it is called photochemical reaction. And this is an example for photochemical reaction. And this concept is very important in the examination point of view, as more number of times they have asked this question in the examination. Is very important. Types of decomposition reaction, definition, and one example. Okay, please do practice this. And I have given the procedure for some of the important activities to be asked in the examination. But I have given procedure for important activities. Please do practice them. Particularly electrolysis process and lead nitrate, decomposition of lead nitrate, and these definitions. Dear students, now it is time up. Let's go for concluding the class. So today, please go for practicing these without fail. Okay. Tomorrow, I'm going to continue the same chapter. So with this, let us stop the class. Thank you very much.
Thank you, sir.